Okay, so in this video we're gonna continue looking at right angle triangles. Last time we were finding lengths, but this time we're gonna learn how to find angles. So just to remind you what the functions were, there was sine, which was the opposite over the hypotenuse. We had the cosine, which was the adjacent over the hypotenuse, and the tangent, which is the opposite over the adjacent. And we also had the inverse functions like this that it can be written as arc on your calculator, just depending on what type of calculator you've got. So after reviewing them, we're now gonna look at some problems. So the first problem is we want to find this angle x, yeah, and we know that this length here has 10 and this length here has 7. So first of all, we need to figure out which ratio, which function we're going to use. We happen to know the opposite and the hypotenuse here, so we're going to use the sine. So that's opposite over the hypotenuse, that's 7 over 10. But we don't want to do the sine of that because we want to figure out this angle here. We don't know the angle. So what we want to do is we want to find out the inverse sine. We want to find the angle that has a sine of 7 over 10 or 0.7. So in your calculator you put in or 7/10, whichever you prefer. And then we'll find the angle, so you put sine to -1 or arc sine, depending on what your calculator says. And then you put in the number 0.7 and we'll get what angle we're gonna find. The angle only to one decimal place because you don't generally put as many decimal places for angles. So it's 44.4 degrees. Make sure you put the unit of measurement you're using. So next problem, we again want to find this angle x. We know that the hypotenuse is 8 and the opposite is 3. So again, we're going to use the sine. I don't want to write that down yet. So the sine is 3 over 8. If you want to write that as a decimal, it's 0.375. Because 1/8 is 0.125, and then when you times that by 3 you get 375. So we want to do the inverse sine of 0.375. And remember, when we're doing this inverse, what we're really doing is we're finding an angle that has a sine of this number here. So really what you're doing is you're doing these backwards. That's the backwards one version of that, and that's the backwards of that, and so on. These are just... So now we'll type it in with calculator. Again. And we're going to get 22 to 1 decimal place. So x is going to be 22 degrees. Because the next digit's a 0, so we can just get rid of that. But if you, to show that you've rounded it to 1 decimal place and not the nearest whole number, you would actually still write that. But I'm just writing 22 because it looks better, in my opinion. But in an exam, if it tells you to round to 1 decimal place, write that, or you might lose marks. We've got one problem here, and this one we're going to use a different function because look, in this one we're given the hypotenuse and the adjacent. So for this one we're actually going to use the cosine. So that's 11 over 16, and we want to find and that'll give what x. So let's see what we get here. Oops. Typing in the wrong buttons here by mistake. That is not actually a sensible answer. That's because I've put cosine instead of inverse cosine. Right. Let's see what we get. We get 46.6. degrees to 1 decimal place. Let's just rub some of this off so that I've got a bit more room to write the working out for this last problem. In this last problem here, we're given the opposite and the adjacent to the angle. So in this one, we're going to use the tangent. So the opposite 6, which is the top one here, and then the adjacent's 9 centimeters. So we've got 6 over 9, and then we want to find an angle that has a tangent of this number here, 6 over 9. Obviously you can see that that simplifies to 2/3. So you can put either in your calculator and you'll still get the same answer because we already know that them fractions are equal. So I type that in my calculator, put in my fraction, find the inverse tangent of that. We'll find out that this angle here is 33.7 degrees to 1 decimal place. So that's how we find angles. And in the last video we learned how to find lengths. So in the next videos what we're going to do is we're going to learn how to apply these, and we're going to use them to find both lengths and angles in some applied problems, including angles of depression and elevation problems. So that's next video, and we're also eventually going to learn how to apply it in other shapes like squares and then eventually 3D shapes.